Okay, we should be live. We are going to get things started. So I'm Emily Harden. I'm the Executive Director of Techlahoma Foundation. Thank you for joining us today. We're Free Code Camp, Oklahoma. Thank you especially to all of our volunteers and our speakers, hint Floyd, who is about to speak to us. First thing, this user group is sponsored by the Techlahoma Foundation. Techlahoma is a nonprofit volunteer-run organization. We have 24 different user groups that meet monthly, 3 conferences that we have every year. We sponsor free local tech events all the time. Our goal is to enrich Oklahoma's technologists of all backgrounds through education, connection, and opportunity. If you have any questions about that, you can learn more at techlahoma.org. If you're on our Slack, you can also @ me. I'm Emily H, and I'm happy to answer any questions in our Slack. Speaking of that, join us on our Slack. If you go to slack.techlahoma.org, you can see it. You can also go straight to join slack.techlahoma.org. Either one should take you straight to Slack. And we'll be chatting in our free Code Camp channel. Code of conduct. This is like the biggest thing that we need to talk about. It's very important to us that our members feel safe and respected and comfortable in all of our spaces. And so if you have any issues with anyone's behavior or any sort of conduct issues, please message at conduct or contact conduct.techlahoma.org, which allows you to submit an issue. That way it can be reviewed by our conduct committee. If you have any questions over that, please contact at conduct, and we'll be happy to help you. Thank you, as always, to all of our sponsors. Right now, we have 2 sponsors of our user groups, Bison Technologies and Heartland Payment Systems, and really appreciate them helping sponsor us. If you are looking into other events that Techlahoma does, check out meetup.com/pro/Techlahoma or our Slack. Again, we're going to be going right back to the Slack again in our channel events. There's all sorts of events people post in there, including Techlahoma ones and non-Techlahoma events. So you should definitely check it out. The biggest event that's coming is 200 OK. So this is June 3rd. Right now, you can use code EARLYBIRD to get $25 off your registration. I highly recommend that. Starting, what's this next month? May 1st. You won't be able to use that code anymore. So I definitely recommend it. Register at 200ok.us. We are planning, and I've just ordered some of the swag, and it's going to be some pretty cool swag. So I'm pretty excited. And with that, I'm passing it to Floyd. Floyd started his very own company, Canyon Trail, and I'm excited to pass it off to him.
Awesome. Thank you so much, Emily. Let me get my Prezzo up. There we go. All right, cool. So before I get started, big shout out to Techlahoma and to Emily for sort of roping me into this. You can always nerd snipe me by like, hey Floyd, there's this group that really needs a talk, like somebody to pour into them a little bit, and I'm like, okay, I'll do it. So thank you, Emily, for doing that. Also, just want to give a shout out to Techlahoma in general. It's a fantastic organization that I've had the privilege of being involved with for a number of years, and they've really bent over backwards for me in a number of different ways and created opportunity for me. So freaking love everybody there, and they are awesome. So let's talk. So my name is Floyd. My company Canyon Trail is all about helping others build high quality software, whether that's individuals, whether that's people that I get to hire and train up, or if that's people that I'm serving as an advisor or their clients where I'm helping them build some software. For me, it's all about improving the industry, helping people learn how high quality software is done. My Twitter handle is @SoftwareFloyd. So if you want to like snap a screenshot or something at some point during the presentation, feel free to do that. I love tweets, so make the tweets. So the title of this presentation is Human-Computer Emulsion. Well, so what's an emulsion? An emulsion is when you take two things that don't really like mix properly, like oil and water, and you find some way to sort of force them to work together properly so that they don't just kind of separate back out, you know, like mayonnaise or salad dressing or Congress. And, you know, this emulsion that we're talking about is taking two things that don't really mix very well, these illogical and sometimes inconsistent and unfortunately bad at communicating humans, and finding a way to make them mix with computers. But these don't really mix that well. So what we're going to be talking about today are some of the false emulsions that we in the software industry sort of let ourselves believe that are actually just going to eventually separate, and we're going to start feeling the pain of, okay, we're treating computers like humans, or we're treating humans like computers. Let's find a way to make these work together the right way. And we're going to talk about some recipes. How do we make humans and computers actually work together and mix together properly so that we can actually get something useful out of it instead of this weird separated soupy mess? You see, humans, we're creative, we're intelligent, but we're also kind of slow at stuff, especially when you compare us to computers. We're really, really bad at tedious tasks, especially if we're like stressed out or frustrated. We skip steps, we forget things, we mistype things, and we're kind of unpredictable, woohoo, but computers, on the other hand, they're mechanical, which means there's not a whole lot of creativity into what computers do. They just kind of do what they're told, specifically, precisely, annoyingly. They're not very smart, but they're very fast and they're very precise and they're really, really consistent. So all of those like boring, tedious tasks that humans really suck at, computers are really, really good at. And all of the stuff that humans are really good at, which is creative thinking, problem solving, lateral thinking, thinking outside the box, that kind of stuff, computers are terrible at. So good recipes for making an emulsion out of humans and computers, it puts humans working in their strengths, and that's also to say it keeps humans working outside of their weak areas. And the same thing is true of computers. We want computers to do what computers are good at. So let's talk about testing. So here's a little snippet of pseudocode. So here's some function main, and we're just going to pretend like we understand what programming language this is, and it doesn't really matter because it's pseudocode. Okay, whatever. And we have this function here that's highlighted called do the thing. Now, let's say as programmers, we need to add a setting so that do the thing is controlled by this setting. So if the setting is enabled, we do the thing. And if it's not, we don't do the thing. Now, here's the first false emulsion about mixing computers and humans together. And that is good programmers run the app and test their changes manually. So here's the problem with that. The truth about testing when you're adding features is that when you add a feature usually, if you boil it down to its most basic, most concise, it boils down to a conditional. And what's a conditional? It's an if statement. It's a loop. It's these programming constructs that say, if this condition evaluates to true, do this thing. Otherwise, do that thing. Now, every time you add a conditional, you're doubling the paths through the code that need to be tested. So I generally refer to that as the testing burden. So anytime you add a conditional, you double the testing burden of whatever code it is that you're modifying. So the problem with that is that you have an exponential relationship between features that you add and the testing burden. So let's see this visually. Let's see this graphically. This is what that means. So at 6 conditionals, you've got about 64 paths that you've got to test to prove that your code is working the way it's supposed to. At 8, you're over 250, and at 10, you're well over 1,000. That's a lot of manual testing, a whole heck of a lot. You see, one of the other problems about testing is that it's repetitive and it's tedious. And it really, really needs consistency. It would kind of be a bad thing if you just sort of fudge your way through the testing and you miss something. It seems like this doesn't really make a whole lot of sense to have humans do. One of the other problems is that if we were to actually be honest and do this manual testing according to this false idea that programmers are supposed to do all of their testing manually, you'll start out on a project and you'll spend most of your time coding. This is this area in green. And the more features you add, the more of your time eventually, until only the slightest, teeniest, tiniest little infinitesimal fraction of your time is spent programming and the rest of it is spent testing. You see, when you argue with exponential math, the math usually wins. So here's another false idea about testing. Good programmers know how to make changes without breaking things. So the idea is that you're smart enough and that you've done enough analysis to make changes to code without breaking anything. This is what they're saying, that your brain is just big enough and just awesome enough that you can fit all the details in your head and figure it out. So let me add some reality to this. A small code base is usually less than 10,000 lines of code. A medium-sized code base could be tens of thousands, could be getting close to 100,000, depending on what language it is. You know, the lines are blurry. Large code base could be hundreds of thousands of lines of code, maybe even a million or two. An enterprise class software suite is going to be well over 1 million lines of code. Most operating systems have tens of millions of lines of code. Even the smallest code bases at thousands or tens of thousands are too big for any human to fit in their head. So what do we do about this issue of proving whether or not our software is working the way it's supposed to? We got to do some automated testing. We want to let the computer be doing what it's good at, which is the tedious stuff. You see, automated testing, usually the foundation is what we call unit tests. Good unit tests, they run quick. And when I say quick, I mean like less than 10 milliseconds. So when I say quick, that means dozens, hundreds of unit tests should be able to run in a second. So being able to rerun a whole bunch of unit tests really, really quickly gives you this really, really fast feedback so that you can make changes quickly and know whether or not you broke stuff. They're pretty easy to write because they should be pretty small. They have a high locality of failure. So what does that mean? That means if you have a test that's breaking, the test should help reveal what area of the code is broken, and that area should be pretty small. And the idea behind this is it enables confident coding. You can make code changes ruthlessly and not have to stress about, what did I break? Did I fit all the details in my head? What if I don't know all of the details and I missed something? This is what these tests are for. They make it possible for you to use the human parts of your brain to be able to make judgment calls and get creative about how you solve the problem without stressing about, did I forget something? So now let's talk about deployments. So what's a deployment? Well, that means taking the stuff that works on my machine and making it so that that stuff works for the end users, the customers. There's a false emulsion that we tend to believe about deployments that bites a lot of people, and that is, we're going to make a checklist. We're going to make a checklist. So in order to take whatever code that we've all built and it's checked into source control or wherever we keep our code, we have this list that we follow in order to get that code into whatever production environment it is or whatever testing environment it is. So here's this definition that I've put together. A deployment checklist is a precise, ordered set of instructions for one or more people to follow to deploy a new revision of software into a given environment. Now I'm going to highlight some words here, and I wonder if you're going to notice this. You might have already noticed it too. Precise, ordered set of instructions for one or more people to follow. These things probably don't mix very well because people kind of stink at this whole precise and doing things in the right order and doing it exactly the same way every time. Humans are really bad at that. Let me tell you a story about this, as a matter of fact. So once upon a time, I worked for a company. We built an application that had two major components. There was a piece of software that installed on people's computers. It was Windows software. And then there was a server-side component that this software talked to as well. So whenever we needed to deploy a new revision of this, we would shut the server-side system down and we would put up messages being like, okay, everything's going to be shut down for a while we do some maintenance. And then they would bring in pizza for all of us at 6 p.m. So the shutdown would start at 6 p.m. They'd bring in pizza, they'd bring in beer, and it's like, okay, we're here until it's done. Ostensibly, the whole deployment checklist thing was supposed to be finished in like an hour or less. It was rare we got out of there before midnight. It was not uncommon to be there until 2 or 3 in the morning. And this was awful. It was just terrible. You see, what usually happened was we would try to do the deploy and then, oh yeah, all those changes that we made over here in this environment manually, because they were manual changes, we're gonna have to figure out how to do that again in the production environment where the stakes are high. Um, and we hope that we do it the right way. And then once that's all done, we're gonna do some testing. Of course, manual testing, which is awesome. Not. And inevitably, we found stuff. Okay, guys, it's broken. We got to start all over. So we would start all over, rinse and repeat until we were all sleepy, sleep deprived, had too much pizza, probably had too much beer. It's 1 in the morning, and we're trying to get this software out the door. Good things did not happen this way. You see, deployment checklists are terrible because it means it's tedious work done by humans, and especially when you've got humans that are sleepy, overfed, frustrated that they're at the office at 2 in the morning. That's not a good idea. They're slow. And then here's this really nasty part of deployment checklists. They tend to be incomplete. Why? Well, because usually there's this idea of implicit knowledge that's hidden inside of deployment checklists. What is implicit knowledge? It means this person who wrote the checklist or wrote that part of the checklist assumes the person reading the checklist knows what I know. That's never true. It's never, ever, 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 ever true. So what that means is whoever follows the checklist, if it wasn't the original author, or maybe it is the original author who forgot what they were thinking when they wrote the checklist, steps get skipped. And that tends to be a problem. So what do we do about that? We have got to figure out a way to automate our deployments because beer, pizza, and humans and sleep deprivation, your clients might not be terribly happy about being, having processes driven that way. And honestly, it's going to cause some issues. A good deployment should be this easy. You should be able to click a button or run a script and it just goes end to end. So let's talk about some tools for automated deployment. Scripting. So this is Bash scripting. This is PowerShell scripting. Whatever scripting language or scripting environment that you like, you can write deployment scripts in Python if you want to, whatever. There are infrastructure as code tools. So this is really, really cool because you can write a program to define your infrastructure and then run the program, and the program creates or modifies the infrastructure to fit what your program says it's supposed to do. So these are tools like Terraform or Pulumi. There are GitOps tools like Circle CI or GitHub Actions that will automatically run your deployment scripts whenever people make changes to your source control. And then, of course, there's excuse me, I can't word today. There's containerization, things like Docker, so that it makes it a whole lot easier for you to ship the correct environment to wherever it needs to go so that you don't have issues where it works on my machine, but it doesn't work in production. Why? Containerization can really help with that. Okay, so now let's talk about the software development process. So as programmers, our job is really to take one human, the idea, they say, it'd be great if I had some software that did this, and then this, and then this, and turn these I want statements into stuff that a computer can understand. This is software development. Usually, it's more than one person, though. And the thing is about humans is that sometimes getting the I wants from these humans is kind of messy. Sometimes they disagree. Sometimes it's inconsistent. One person says this, one person says that. Sometimes one person says one thing one day and they say the exact opposite the other day. This is kind of messy. And honestly, some of this human communication stuff, it kind of oozes a little bit. Ew. And the problem with software development and this process, which is actually very fundamental to software development, is that you get this situation constantly, where you build some software and then one of these people that you're supposed to be building the software for says, well, that's not what I wanted at all. And they get frustrated. So the falsehood that a lot of people will believe about, well, how do we deal with that? Well, we're going to get all of the requirements, that is the I want statements, written out in enough precision so that we know actually what to do. We're going to get them all up front, and we're going to say, okay, is this what you want? And they're going to say, yeah. Okay, we're going to go build it. You sure this is what you want? And they're going to go, yeah. And then we're going to go build it, and they're going to still say, that's not what I wanted. So the challenge with this whole upfront requirements issue is that we spend a lot of time and a lot of effort, and it's usually frustrating effort. It's really, really difficult to get people to say, yes, this is what I want, and just spend weeks and weeks and weeks and weeks doing that and picking it apart into teeny tiny little precise details. The intent for this whole upfront requirements gathering thing is that step one, we get the requirements, we get the customer, we get the client to say, this is what I want in very, very precise detail. And we say, okay, we're going to go build this. Anything else? No? Okay, good. We're going to go build it. And then we disappear for a while and we go build the stuff. And then we come back and say, okay, here's the stuff that we built according to what you said you wanted. And then we should get paid. But as soon as you hand it to them, and they're going to go, wait. This doesn't work right. This isn't what I asked for. Well, yeah, it is, because here's the requirement that said, this thing should look like this and this thing should act like this. And that's exactly what we built. Well, but that's not what I meant. So, unless you really, really like contract negotiation and lawyers and stuff, this is really kind of painful. Generally, this is why. You see, humans, in all of our messiness, but also in all of our creativity and intelligence, we can attend the same meeting, listen to the same nutty guy talk to you in a user group talk, read the same email or the same document, and say, I'm pretty sure we agree on all of this, and have completely different shapes in our head. And it isn't until we actually take whatever it is we think we know and find some way to express it tangibly that we go, we don't agree as much as we think we do. And we've got some work to do. And that work is probably one of the most important bits of work in software development. I say this all the time. If you've ever worked with me or worked around me or spent more than about 17 minutes near me, you'll hear me say this constantly. It's only about 30 or 40% of software project success that's based on technical execution. If you're an awesome programmer, congratulations. You can be responsible for no more than about 40% of whether or not your projects succeed or fail. The rest of it is dealing with this messiness of getting the truth about what software actually needs to be built, what's actually supposed to get done. So, what do we do about that? Well, here's one recipe: feedback loops. Feedback loops give you an opportunity to fail smaller, because you're going to fail. And especially if these are stakeholders or clients that you've never worked with before, you've never communicated with them before, you're going to fail. You're going to have some misses in understanding. You're going to have issues where you have a different shape in your head than they have in their head. This is going to happen. So it's better to do that small and fast so that you can learn from that and you can course correct instead of having big and unavoidable failures. So what does a feedback loop look like? Well, you build a little bit of software, and then you show it to the customer, and then you get their feedback. You use that feedback to make more plans for what else you're going to build, and then you go build some more. Now, it's this area right here that's going to have that oozy, messy part that is all completely chock full of human interaction. But it's also the most important part in finding those creative solutions, harnessing human ability to think outside the box and figure out, okay, what do we really need? So this is the part that can sometimes feel sort of businessy and icky, but honestly, if you're good at this part that's highlighted here, you can be an amazing programmer, because this is where the magic happens. If you're good at this and you're good at turning this back into more software that works well, this is really where the magic is in the software development process. So what does this look like? How does this actually work step by step, loop by loop? So let's say we build 4 features and we hand it to the customer and say, okay, well, what do you think about these 4 things? They're going to say, well, this stuff works and this stuff works and this is okay, but this part here, it doesn't work right. We don't like it. So then we're going to take it away and be like, okay, well, we're going to go build some more. What about this? Okay, this stuff works good. This stuff over here, not so great. Okay, well, we're going to just keep going, and we're going to keep adjusting what didn't work, and we're going to keep building more, and we're going to keep going. We're going to keep going, and we're going to keep going, and eventually we're going to get to a point where you're pretty pleased with whatever it is that we've built. So you see, feedback loops, they give you this opportunity to find those. We've got different shapes in our head from that graphic earlier. We want to find that early, not only because we want to course correct in the software that we build, but we also want to be able to learn how to communicate, because we're unique, we're individuals, and communicating with one person and getting to the core of what is it that they really need, or what is it that they really want, is going to work completely different if you replace that person with a completely different person. So it's not just about what software do you build, but it's also about building that communication relationship so that you can understand each other. We call this shared understanding. And building shared understanding is very unique to each and every relationship. Feedback loops give you the opportunity to course correct before it's too late. Instead of investing an entire project's worth of software development effort, only to realize at the very end, oh, we completely missed something key, we can usually find that and course correct it early when we use small feedback loops. And then it also gives us the opportunity to find shortcuts. Well, what does that mean? Well, shortcuts are when you build a little bit and you show it to them and they go, wow, we were expecting this to take like 6 months, but you've covered like 90% of what we need. Can you just change this and change this and change this? And I think that's probably all we need. Feedback loops give you the opportunity to do that. And believe it or not, it actually does happen in software pretty often. Not all the time, not something that you should count on, but it does happen. So some key ingredients in feedback loops. What are some key ingredients? The first one is it's got to be hands-on with the realest users available. And I think I inventified a word when I said realist. If you can't get it in front of real end users, you want to get it in front of people who know the real end users really, really well, because that feedback that they give you is going to be the most important. The closer you get to real users means this is real world feedback instead of I think. You want that loop to take no more than a couple of weeks. And if you can shorten it even smaller, where it's a couple of days, even better. Getting no negative feedback is generally a bad sign. So if your client, if your customer, every time you bring new software to them, they're like, yeah, sure, looks great. Be worried, because it probably means they're not looking at it close enough to really give you the truth about where you are and where you aren't aligned, where the shapes are different and you don't know. And also, the feedback loops really need to work with evolutionary design. What does that mean? Guess what? We're going to talk about that next. So evolutionary design is all about keeping the big picture in view, even if that big picture might change a little bit. This graphic here, courtesy of Henrik Nieberg, it's actually a really famous set of graphics in the space. So if you notice, we're building a car in this graphic, and we're building it, sort of like a factory would. So we're gonna build a wheel, we're gonna build a chassis, we're gonna start putting the body on the chassis, and then eventually we're gonna have all of the bits and bobs of an actual car built out in phase 4. The challenge with building software in this particular way is that the end goal of that software is assumed at the beginning. So it's like, okay, we know what we're building. We're just going to keep building until we get to the thing that we know that we're building. Like we talked about a little while ago, usually the thing we think we know is wrong. As a matter of fact, the beginning of the project is usually the moment of maximum ignorance. It's the moment where you know the least about what really needs to happen. One of the other issues with this is that the only really meaningful feedback that you're going to get from the customer in phases 1, 2, and 3 is this: it's not done yet. And that's not really particularly helpful in course correcting if you've made a bad assumption or if you haven't got some key information about what their needs are. So the full graphic from Henrik Nieberg is this, where it's a whole lot better to present to the customer early on something that's definitely not going to meet their needs, definitely not precise and complete enough to meet their needs, but it gets the general idea across in a way that they can actually use. And so this is the skateboard in phase 1 at the bottom. And the kind of feedback that you should probably be getting from your end users if you give them a skateboard is, well, I can't go very far with it, and I can't take a passenger with me, and I fall off a lot. Can you do anything about any of that stuff? And then evolving it to a scooter might mean, well, I fall off less, and I think I can get a little farther, and I think I can get a little faster, but I can't go very fast, and I can't go very far. What can you do about that? Okay, well, let's evolve that into a bicycle. Okay, I can get a few miles without getting real tired. I really like the feeling of wind in my face too. That's nice. Oh, okay. So, okay, let's evolve that into a motorcycle. Okay, we get a motorcycle now. Oh, the wind in the face. I'm really feeling that. I love it. It would be a little better if like I didn't have to worry about it tipping over though, and I still would like to be able to carry somebody with me. You know, maybe I could take my wife out to a date or something like that. Then we get a convertible. And if you notice, the convertible is different than the end goal that we built on the top row. Why? Because we used the feedback that we got along the way to reshape what the end goal was. And that's exactly what evolutionary design is all about. We want to incorporate feedback that we get along the way to help us steer and get to something that delights the customers, something that they actually want to use, something that they actually like, instead of something that they're just like, okay, we checked all the boxes. Evolutionary design really is all about showing the design early and often, asking the question about, well, what's the most important thing? What's important to you that we haven't gotten to yet? What do you still need? Have we solved most of the problems? Have we solved any problems yet? Um, Figuring out whether or not we've solved problems. So at this point, let's go back and let's talk about some of these points that we've made and sort of revisit it. Number one, humans and computers, we really don't mix. Humans are very slow, unpredictable, but creative and intelligent. Computers, they're fast, precise, mechanical, and kind of not very smart. So we want to let the computers do the tedious stuff. We want to let the computers do the things that are repetitive, rote, mechanical, um, stuff that requires lots and lots of typing, stuff that requires attention to detail. Let's let the computers do that stuff because humans are really bad at it. We want to harness humans' creativity, even if it's messy, even if it requires having lots and lots of conversations, and even if it requires having to sort of, work at getting the information out from people. Because in that's where the magic happens. And that's where we can really, really get to a point where we can delight our customers in the software that we build. And we can earn their trust by building high quality software where the computers are testing it, deploying it, where all of that stuff is done. And then we can focus on the human stuff, like humans that we are. This was too awesome. You have no questions. That's all I got.
Thank you so much. I really appreciate it. I'm checking. I'm not seeing questions on the one place. Let's see. Doesn't look like we've got any other questions yet. But overall, I really want to thank you for your time tonight. I think we learned a lot here. We all tend to try and do things by ourselves and get things done. And, you definitely hit home that we can't do that. So I appreciate that. If anyone wants to join us, I will send the link to the Zoom call on our Free Code Camp Slack channel. So if you have any questions there, feel free. And also, oh, we have a question. It's pending. It's coming. While we're waiting on the question, I would say to register for 200 OK if you haven't already, because you definitely should. Looks like we've got a question from a GA Watson. Let's see what we've got. While we're waiting, if anyone has any random, oh, here we go. You mentioned no negative feedback is not good. Any tips if that does happen? That's a great question.
I need to sneeze, just a second.
Okay. Bless you.
I think I'm okay.
All right.
This is that time in Oklahoma where there's this yellow dust on everything.
Right.
Okay. No negative feedback. Okay. So this is where you've got to really lean in and encourage people to be candid. We're in Oklahoma, and Oklahoma is really bad about politeness. Like you go to the grocery store and you try to open the door for somebody, and they're like, "No, I'm going to open the door for you. This is a politeness contest." Urgh. And especially in this area of the country, we're really bad about getting people to tell us the truth if the truth isn't positive. And you've really got to work at making it okay, making it safe to do that. Sometimes you got to lean a little bit into vulnerability and show them a work in progress that's not very polished yet, and point out, okay, ooh, that's kind of gross. This is still a little clunky. What do you think? Is this too clunky? Does it need a little bit more work? Sometimes you've got to kind of try to plant a little bit of seeds of inviting some critique.
Okay. Yeah. So not necessarily discrediting your own work, but showing your work a little bit earlier in the process, maybe if you know that you're going to have struggle getting negative feedback from someone.
Yeah,
Got it.
absolutely. Great question.
Any physical methods/practices you can use to prevent the feedback loop early on, like diagrams, they said.
Can you repeat the question? I'm not sure I followed it.
Any physical methods/practices you can use to prevent the feedback loop early on, i.e. diagrams.
Well, the feedback loop is a good thing. You want it.
Okay.
So early on, generally the thing is you're going to have to spend that effort getting your customers, getting your stakeholders engaged in it, where it doesn't just turn into a status meeting. Because that's like the worst thing possible. If you've got an opportunity to do things like plant metrics in your application where you can actually see whether or not they've logged in, you can see whether or not they've used stuff. That's a great way to do it. And you can sort of gently push on it, like, okay, at the next time we get together, hey, I noticed nobody's logging in and using the app. We really need your feedback to confirm that we're understanding your needs.
Mm-hmm. Mm-hmm. So making sure it's a you're not having any meetings that could have been an email, basically.
Right.
Yeah.
Right. And that, that's again one of the hard things about human interaction too. Meetings are for collaboration. Meetings are not for divulging information, right?
Mm-hmm.
Because if you're going to build a little bit of software, you're going to do a demo at the meeting, and you don't really care, or you're not inviting feedback, or you're not going to get any feedback, then yes, that should have been an email and maybe a video,
Right.
because the communication flow is only going one direction. Meetings are for two directions of communication or more. This is where people are both listening and speaking.
Cool. Perfect. All right. I think you really answered all of the questions that we had. Everyone's complimenting the talk, so we really appreciate it. Like I said, I will copy this link in as soon as I stop streaming. So you all have a wonderful rest of your evening, but feel free to join us on Zoom. I'll have it in the Slack in about 2 minutes.
Thanks for having me.
Thank you.